Okay, so let's take a look at simplifying rational polynomials. So this is going to involve a lot of factoring. So we've been reviewing factoring for a while now since the last unit. So we should be good to go. Okay, so first we're just going to be simplifying. In order to simplify, step one is going to be factor as much as possible, including the GCF. And then you're going to simplify any common factors from the numerator and the denominator. There's no equal signs in these. You're not solving, you're just simplifying. So 3x squared minus 12. When I look at that problem, I notice it has a GCF of a 3. So the 3 comes out, and I'm left with x squared minus 4. So I start with GCF. Then I notice that one also has a difference of squares. X squared minus 4 is a difference of squares. So I know I can break that up into x minus 2 times x plus 2. For the bottom one here, it's a trinomial. The a value is 1. So I'm looking for two numbers that multiply to 10 and add to 7. And that's going to give me 5 and 2. So I guess I'll put it right here. So I'm going to go ahead and I'm going to take this and I need to simplify it by factoring out or canceling out any factors from the numerator and denominator. Notice the x plus 2's are the same. If they are the same on the numerator and the denominator, they cancel. Nothing else is the same. That is it. That is going to be my final answer. So my final answer is 3 times x minus 2 all over x plus 5. Done. I would expect to see the answer above here as your work and see what you cancel out. Okay, let's take a look at number 2. Same thing. You look at the numerator and you're going to factor it. How are we going to factor it? Once again, this one has a GCF. Always check that first. 12 and 36, I can take out a 12. X to the 5th and x to the 4th, I can take out x to the 4th, which leaves me with an x plus 3. That's all I can do. I'm done. The denominator, guess what? I can't do anything with. It's just simply a 6x. So now when I go to simplify, 12 over 6 is simply a 2. X to the 4th over x, when you divide, you subtract exponents. That leaves me x cubed. And I still have an x plus 3. That is my final answer. I'm done. Okay, number 3. So I'm going to go ahead and take a look at the top. Again, this is a trinomial, but the a does not equal 1, so I'm going to have to split the middle. So here it's multiplying to 2 times 5, which is 10, and adding to 9. So I'm going to do some of this work here. So two numbers that multiply to 10 and add to 9 are going to be, oops, I have a sign error. It's going to be a minus 5. So fix that. This is a minus 5. Sorry. So it's really going to multiply to negative 10. I knew I had one error in here and I found it. Multiplies to negative 10 and adds to 9. So you're going to go ahead and say that that is positive 10 and negative 1. So we're going to go ahead and do a positive 10 and a negative 1. So that multiplies to negative 10 and it adds to 9. Bring down the negative 5, bring down the 2x squared. Group the first two, group the last two. The GCF of the first one has 2x, leaves me with an x plus 5. The second one, the GCF is negative 1, leaves me with an x plus 5. So I have 2x minus 1 times x plus 5. So that is my factored form of the numerator. Okay, my denominator is multiplies to negative 25, adds to 10. I don't need to split the middle because it starts with an x squared. The a value is 1. So multiplies to 10. I'm sorry, yeah, multiplies to negative 25, adds to 10. So when I think about that one also has an error. Change this to a plus sign. I must have just flipped that when I was typing it in. That should be a plus 25. Otherwise it doesn't work, which was not my plan. So here again, multiplies to 25 adds to 10. So that's going to be 5 and 5. So x plus 5, x plus 5. Or you can write that as a binomial squared, x plus 5 squared. Now that we factored, you can cancel. The x plus 5s are gone. So my final answer is simply 2x minus 1 over x plus 5. Okay, so that's the simplifying. We're going to be doing more with it. We're going to be adding, subtracting, multiplying, and dividing with these. So let's take a look. Multiplying, the directions are really going to be the same. You're first going to factor the numerator and the denominator. And then again, you can go ahead and cancel any factors out. So simplify any common factors. Okay, so for the first one, it's just more work. You have 4 things to factor. So the top part, we're looking at 2 numbers that multiply to negative 12 and add to 4. So that would be x plus 6 and x minus 2. So 6 and negative 2. Then, and it doesn't matter which way you go, the next one, this is a difference of squares. So I'm going to go ahead, and this is going to be x plus 3, x minus 3. Okay, moving on to the denominator. This one is a trinomial, multiplies to negative 6, adds to 1. That's going to be a positive 3 and a negative 2. And then my last one here is a GCF problem. I can take out a 2x, which leaves me with an x plus 6. So you factor all 4 parts instead of 2 parts. Because it's all multiplication and division, again, you're just going to go ahead and cancel. So I'm noticing x plus 6 and x plus 6. I'm noticing x plus 3, x plus 3. And that's it. So my final answer is going to have an x minus 2 times x minus 3. My denominator doesn't matter the order, but a lot of times we put the GCF in the front. You don't have to multiply that out. You can leave it factored. Oh, wait. Silly me. X minus 2 and x minus 2. Those cancel. Gone, gone. Let's just rewrite this. There we go. We have even less things. Okay. If there is a division problem, it's going to be very similar to multiplication, except that you have to flip your second fraction. So you're going to flip this one right here. So I'm going to rewrite the problem just because it's easier then. So this part stays the same. And to turn division into multiplication, you're going to flip the second fraction. So now 5x cubed plus 20x squared is on top. And the 6x is in the bottom, in the denominator. But the same thing is going to apply. Now I'm going to go ahead and factor each part. So this top one here is a GCF problem. So this has a GCF of 6x cubed. And then I'm going to go ahead and see what's left. That's an x minus 4. And then my next part here, this is also a GCF problem of a 5x squared is the GCF. Leaves me with an x plus 4. This one here is a difference of squares, and we should be getting really good at recognizing these things. You don't have to write the names. I just like to be exact in your notes when you go back and reference it. And the 6x, you can't do anything with. It can't be factored. So now we're going to look for common factors and cancel them out. So I'm noticing an x minus 4 and x minus 4, x plus 4, x plus 4. And now it's kind of up to you how you want to do it. You could simplify the top and then divide by the bottom, but I'm also noticing 6 divided by 6 is gone. So the top, and again, more than one way to do this, the numerator, we have an x cubed and a 5x squared. That's going to be 5x to the 5th. When you're multiplying, you add exponents. The denominator just has an x left. Well, we can simplify. X to the 5th over x is truly just 5x to the 4th. So look how nice that entire problem simplifies to. Okay, we are also going to add and subtract with a common denominator. So if it has a common denominator, you simply are going to just add straight across and keep the denominator the same. It's kind of like when you do 1/4 plus 2/4. You could say 1 plus 2 is 3, keep the denominator the same, 3/4. Same with subtracting. So let's see what happens here. So we know automatically that the denominator, since it is the same already, it's going to stay x squared minus x minus 12. The top, we can add x squared plus 3x. Since it's a plus sign, you don't have to worry about parentheses or distributing a negative. We'll have to worry about that in number 7. So you add the top, the bottom stays. So if we continue to add the top, that is going to give me like terms. 3x plus 2x is 5x. Now, once I've simplified it, now I'm going to go back to what I was doing before, which is factoring and canceling. So once you add or subtract, then you factor and cancel. So my top part here, I'm looking for two numbers that multiply to 6 and add to 5. So that's going to be 3 and 2. My bottom, I'm looking for two numbers that multiply to negative 12 and add to negative 1. So that is going to be negative 4 and a positive 3. Now that I've factored, now I can cancel. X plus 3 and x plus 3 is gone. So my final answer here is x plus 2 over x minus 4. Done. You can't cancel your x's. That is, you have to cancel all of x plus 2. So sometimes I see people try to do that. You cannot do that. Order of operations says you can't. Okay, the next one is a subtraction one. It's very, very, very similar. Except you have to remember when you subtract that you need to put in parentheses. That's the most common error because you're going to distribute that negative sign. So 5x is going to stay in the denominator and we're going to simplify the top. So we really have 19x plus 6 minus 4x minus 6 because we're distributing that negative sign. So again, that's where I see a lot of errors, is right there. Oops. There you go. Okay. So when we go ahead and we simplify, we're going to have like terms. 19x minus 4x is simply a 15x. 6 minus 6 is 0, so that's gone. So we really just have 15x over 5x. 15 over 5 is 3. X over x cancels. It's simply a 3. We didn't even have to factor in this problem because it just simplified so nicely. Okay. Well, how do you add and subtract without a common denominator? That's the next thing that we're going to work on. So you must have a common denominator. So in order to have a common denominator, we are going to think about LCDs. So our LCD is when you look at the denominators. Right now we have an x plus 4 and an x minus 2. Your LCD is going to be x plus 4 and an x minus 2. So what you're going to go ahead and do is you're going to multiply the top and bottom of each fraction so that they are going to have the same denominator. So the x plus 4 is missing an x minus 2. Whatever you multiply to the bottom, you also multiply to the top. So we're going to end up having x minus 2. So I'm going to go ahead and do the next part first. So on the second fraction, we have an x minus 2, which means we're missing an x plus 4. So I'm going to multiply that to the top and bottom, which is okay to do. So now what ends up happening is the numerator becomes x minus 2 times x minus 3 plus x. The denominator is simply x minus 2 times x plus 4. Now you cannot start canceling because we have this plus x here, okay? So you have to simplify the numerator. How do I do that? You're going to first have to FOIL this out and then add an x to it. Then we're going to have to refactor it. So x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x plus 6. And then, of course, we have that plus x. Don't multiply out the denominator because we're going to want to put it in factored form. That just makes more work for you. Let's not make more work. So the top, when we combine our like terms, negative 3x minus 2x is negative 5x, plus x is negative 4x. Now we can factor and cancel like we were doing in the other examples. So this numerator, we're multiplying to 6 and adding to negative 4. Let's see, multiplying to 6 and adding to negative 4. Nothing works. 3 and 2, 6 and 1. We're done. That is your answer because that is a prime numerator. So you leave it like that. It cannot factor. Wonderful. All right, let's take a look at the second one, number 9. Well, I guess number 9, not the second one. First thing again is we're going to check for the LCD. X squared minus 4. I'm going to factor this. The other one was factored. This one is not. So it's x minus 2 times x plus 2. Makes it easier for me to find the LCD. So this is really the problem, x squared over x minus 2 times x plus 2 minus 1 over x. So really my LCD, if you look at the denominator, needs to be made up of all 3 of those parts. So the LCD is going to be x minus 2 times x plus 2 times x. So this first fraction is missing an x, so we have to multiply it by x over x. The second fraction is missing the x minus 2 times the x plus 2. So if we go to simplify, x times x squared is x cubed. And the common denominator here is x times x minus 2 times x plus 2, right? They both have a common denominator now. Minus, it's 1 times this. So it's minus, and we kind of already know what x minus 2 times x plus 2 is because that's what this was. So it's minus x squared minus 4. When you go to simplify that, got to distribute your negative sign. And here is my denominator. Once again, you're going to try to factor the numerator. This cannot be factored. It is a trinomial, but it doesn't start with an x squared. It starts with an x cubed. So we are going to keep it like this. You're done. There's no factoring and canceling. Okay, last one. Again, I'm going to factor the denominators to see what they have in common because I need a common denominator. So x squared minus 6 minus x minus 6. We're looking for what multiplies to negative 6 and adds to negative 1. That is going to be x minus 3 times x plus 2. The x minus 1 is going to stay. Again, you can't cancel anything until you get a common denominator. This one down here, we're looking for what multiplies to negative 2 and adds to 1. That's going to be a positive 2 and a negative 1. And the top is 3x minus 5. Okay, I'm noticing for my LCD, I have an x minus 3 from here. I have an x plus 2, which is in both of them. I only need to write that once. And then I have that x minus 1. So whatever it's missing, I have to multiply it by. So this one here is missing the x minus 1. So we're going to multiply by x minus 1 over x minus 1. The second fraction is missing the x minus 3. So I'm going to multiply by x minus 3 over x minus 3. So now I will have a common denominator. We have an x minus 1, an x minus 3, and an x plus 2. The top, we have x minus 1 times x minus 1 minus 3x minus 5 times x minus 3. So you can subtract them with the common denominator. So this is just going to take some algebra work. This takes 2 sets of foiling. So I'm going to have to FOIL and FOIL. So let's see what happens. X times X is X squared. Negative 1X and negative 1X is going to give me a negative 2X when I FOIL, and the negative 1 times negative 1 is going to be a positive 1. Minus, so that was the first part, minus the second foiling here. 3X times X is 3X squared. 3X times negative 3 is going to be a negative 9X. And then I'm also going to get a negative 5X, so it's going to be a negative 14X. And then the last negative 5 times negative 3 is positive 15. And that is going to be all divided by X minus 1 times X minus 3 times X plus 2. Last thing, hopefully, if it doesn't factor, we need to distribute that negative sign to all three parts. So that's going to give us X squared minus 2X plus 1 minus 3X squared plus 14X minus 15. Again, my denominator has not changed. All right, we're running a little bit out of room. X squared minus 3X squared is negative 2X squared. 14X minus 2X is a positive 12X. 1 minus 15 is a negative 14. And everything, again, the denominator has not changed. So we're going to try to factor the top. So let's see. Negative 2 times negative 14 is negative 28. So does something multiply to negative 28 and add to 12? Let's see. 14 and 2. So now we would have to go ahead and split the middle. I'm going to split the middle over here because I'm running out of room. So we're going to split the middle into a positive 14X and a negative 2X. Okay, group the first two, group the last two. So I'm going to pull out negative 2X, which leaves us with an X minus 7. We'll pull out a negative 2. Wait, that doesn't work. Oh, duh, Mrs. Coleus. I'm not going to start the video all over. It doesn't multiply to negative 28. It multiplies to positive 28. Negative 2 times negative 14 is a positive 28. See how your split the middle will tell you if you did something wrong? Okay, does something multiply to positive 28 and add to 12? 14 and 2? No. 7 and 4? No. Wonderful. We don't have to do any of this work because it's not factorable. Silly Mrs. Coleus. This is done. If you could factor, then you would look to factor and cancel.